The stars in the sky are like points floating around in circle. In fact, the word floating point has a special meaning in a programming language like C. Floating point actually means numbers. They are numbers that are different from integers because they can represent values such as 1.4, 10.5, for examples. We will learn about floating point in this video. But we will need the code that we used in the previous video. So if you haven't watched the previous video, watch it first in the link in the description or in the comment. And then you will get the code like this. And we will start by using that code. Please don't just copy the code on the screen here onto your editor because then you will not understand it. But I need you to watch that previous video first before you continue. Let's say that during an economic crisis, the government or maybe a rich person asks you to write a program to calculate how many people are under poverty. That means how many poor people are there in your city so that we can help them. And he gives you one input, which is, let's say for simplicity, is an integer and it is the poverty percentage. And for now, let's assume that it's 5%. So if this number is 5, then that means 5% of the population is living under poverty. He asks you to write a simple program that calculates how many people that is. So we will have a variable, maybe a floating point variable called poverty rate. And that is poverty percentage divided by 100. And from that, we can calculate the number of people under poverty. That is also a floating point. So we will have those two variables as floating point variables. We will call them float. You may wonder, why do we call them floating point? Why floating? Why do we not call them like real numbers? Well, it's a long story because there's something called fixed point as well, but we will not go into that at this time. But in fact, a floating point is not really a real number because it is just an approximation of the real number. A real number can be very precise. It can be like pi, like a non-repeating digits of millions of places. But a floating point is just a simple approximation of that. And the accuracy of a floating point depends on how many bits we give them. For example, if we declared like this, a float would take up 32 bits of memory, and it will be somewhat accurate. But if we change the word float to double like this, it will take up 64 bits of memory, and it will be much more accurate than a float. In a more serious situation, such as when we launch a spaceship to the moon or to Mars, we will always use double or something even more accurate than that. But in a simple calculation like this, a float would suffice. So let's analyze what do we want from this input and output. What is our input? Our input is the poverty percentage here and is an integer. What is the output? People in poverty is the output because we want to know how many people are living under poverty. And how to get there? Somewhere along the way, we have to calculate this variable called poverty rate. Poverty rate is just poverty percentage divided by 100. And after that, we just multiply the poverty rate with the population to get the number of people in poverty. What is the variable for population again? That's right, it's pop. So now that we have the formulas here, it's very simple to write a program. Let's do it. I'll put some comment here to say that this is a calculation part and this is the output part. First, we want to say poverty rate equals poverty percentage divided by 100. So that's this. And then we want to say that the output variable, num people in poverty, that would equal poverty rate times pop. This is too easy, just 2 lines of code. Then we will write the output. So we, of course, will use printf to write the output with the format string. Guess what? Not %d, %d is for integer. What's for floating point? %f, f for floating point. See, %f here. In fact, let's not stop there. We have calculated poverty rate. It would be interesting to see what is the poverty rate as well. So let's also print that out. Okay, ready, set, go. Population, let me just guess, is 532,143. What happened here? The number of people in poverty equals 0.00000. That can't be right. Did we get our formula wrong? No, we did everything right. How did this happen? Let's take a look line by line. Population of Songkhla is 532,143. That's right, that equals to the input. What about poverty rate? That equals 0.0000. No, that's wrong. Let's look at the formula here. Poverty rate equals poverty percentage divided by 100. Let's analyze this line for a little bit. What is the data type of poverty percentage? That's an int. What is the data type of 100? That is also an integer. Even though we haven't declared, it's not a variable, but it has a type. It is a constant of type integer because it is presented as a whole number. In C and in many other programming languages, we have some rules about basic operations. When I say operations, I mean plus, minus, times, divide. That is, int, do something with int, you get an int. Int, do something with float, you get a float. Or float, doing something together, then you get a float. If one of them is a float, then you get a float. If one of them is a double, then you get a double. But if both of them are int, then even if you divide them and the real result in the real mathematical world should be a fraction, should be some decimal places, then it doesn't matter. If int is doing something with int, the result will always be an integer. That's why we get the number 0, because after divided by 100, 5 divided by 100 equals 0 point something, but the result has to be an integer. It doesn't matter if on the left hand side is an integer or floating point. The result was already calculated on the right hand side as an integer, so it will get rid of all the decimal places and it always round down towards 0. That's why you get the value of 0 exactly. But that's not what we want. We want a fraction. We want the decimal places. We want the result to be a floating point. How do we do that? We can do that by something that we call typecasting. Let's say x is an integer and you want to cast it or change it into a float. You do this. Let's say y is a float or a double and you want to cast it to be an integer, then you do this. That's called typecasting. So in this line, when you have poverty percentage as an int and 100 as an int, you can just typecast one of them or both of them to be a float or a double, then it will all be okay. So let's typecast the poverty percentage here as a float. Again, this is not the only way. You can always do something like this, casting both of them, or casting the other one. Can you do something simpler? Yes, you can. You can just add 0.0 after 100. And 100 suddenly will change from an integer to a double. That's the magic. And once it becomes a double, then the result after division will be also a double. And it will be stored in a float variable, which will lose some accuracy, but that will be okay for our application. Let's try. You get a floating point as the answer. Let's try the other way around. Let's typecast the 100 to float. That's correct as well. And now it looks almost perfect, except that I think we get too many decimal places here, don't you think? We just need maybe just 2 places. How do we do that? We change the format string. Here you see %f, that means printing a floating point with some number of decimal places. How many number of places? I don't know, it depends on the system. But if you want to force it to use 2 decimal places, then you do this, 0.2 and 0.2. And let's try. Beautiful. You get 2 decimal places as you wish. Let's try again. Let's do 0.15. 0.15. You actually get 15 decimal places. And you may wonder, what is this 0 here? What if I change it to 20? What if I change it to 5? What if I change it to 100? What would happen? I leave that as an exercise. Try it and see it, how it happens, and then put a comment in the space below the video. Congratulations! In this video, you have learned about floating points, how to declare it. There are 2 main ways, using float or using double. A float is a 32-bit variable. A double means double precision, so it will use 64 bits, and they are more accurate than float. You learn how to take input and print output of the floating point variables. Both double and float use the same format string, which is %f. You can % %f alone, or you can use %1.2 or 0.2f to print 2 decimal places. Of course, you can use %0.5f to print 5 decimal places as well. You learn about basic floating point operations and the operations between integers and floating points. If 2 integers are added, multiplied, divided, or minus together, they will form another integer. If one of them is a float, then the result will be a float. If one of them is a double, then the result will be a double. So if you have 2 integers and you want to divide them and you expect the result to be a floating point, you have to typecast one of them, at least one of them, to be a floating point using the typecasting syntax by using the parenthesis float or parenthesis double as in the example. Alternatively, you can use the notation 0.0. That means if you have a constant integer like 25, you can add 0.0 after it and it will become a double. After that, when you divide it by something or you divide something by it, it will become a double. And that's how you deal with floating points in C. There are more to learn. Stay tuned in the next video.